Alrighty, so mean, median, mode, variance, and standard deviation. So first off, mean. How do we calculate the mean again? Add the numbers, divide by the number of numbers. What was the sum of the numbers?
44.
What was the number of numbers? What's 44 divided by 8? Awesome. What's the median?
5, 5, right?
Hmm?
5, 5.
Why?
Well, don't you take, because it's an even number.
Even number,
You
good.
take the two middle ones
Two middle ones, yes.
and divide or whatever between 5 and 6 is 5.5.
Why is it between 5 and 6? Why is it between 6 and
Because
7?
those
6
are-
and 7 are in the middle.
No.
Okay,
Put them
good.
in order.
Put them in
Sorry.
order first, right? So, negative 1, 2, 3, 5, 6, 7, 10, 12. Then find the two that are in the middle.
It's magic. It's 5 and 6.
5 plus 6 over 2. Hey, isn't that nice? The mean is 5.5, and the median is 5.5. Doesn't always happen, but can happen. And then last but not least, mode.
There isn't any.
None, no mode, there isn't one, whatever you want to put in here. Since none of the numbers repeat, just remember that if nothing repeats, there's no mode. Alright? Alright, now, how about variance and standard deviation? What do I have to do to get those?
Yeah.
A whole bunch of crap.
First,
Yes.
make columns.
Make columns. Good. Folks, a table is a very handy mathematical tool. So, get a row for every one of your numbers. Do I have enough yet?
Yeah, it should be enough. Probably one more line.
One more. Okay. So, you don't have to put the numbers in order when you put them in the table, folks. It's not absolutely mandatory, but it really does make life easier if you do. Negative 1, 2, 3, 5, 6, 7,
10, 12.
10, 12.
Yeah.
10, 12. All right. Now, what's the next column?
X minus mean.
Right. X minus the mean. Please note, folks, you want to subtract the mean, not the median. Now, in this particular case, it didn't make a difference since the mean and the median were the same. But please note that it's only the mean, right? Please be careful subtracting. What's negative 1 minus 5.5?
Should be, how is it, 4.5?
Negative 6.5. Right? Negative 1 means you owe somebody $1. Minus 550 means you owe somebody $5.50. How far are you in the hole? $6.50 in the hole. Now, how about 2 minus 5.5? Negative 3.5. And note, right, to get from negative 1 to 2, you have to go by 3, right? So the fact that your number goes up by 3, that's a good thing, right? So do a little mini checks while you're going. 6 minus 5.5 is 0.5. 7 minus 5.5, 1.5. 10 minus 5.5, 4.5. Last but not least, 12 minus 5.5, 6.5. And again, if you want, folks, since you did not round the mean, the sum of all of these numbers had better be equal to 0. So if you add all the negatives and add up all the positives, they should exactly cancel each other out, wind up being 0. Now, what do you do in the last column then? Square. Exactly. And please do not multiply them by 2. Please note the difference between squaring a number and multiplying it by 2, right? Totally different things. Again, remember when you are squaring those negatives, the negatives will go away. Even if the calculator makes it look like they don't go away, you know that they do. Please don't write the negatives down, all right? So what is negative 6.5 squared? 42 and a quarter. How about negative 3.5 squared?
12.25.
12 and a quarter. Negative 2.5.
6 and a quarter.
We can do the next few. Those are easy. 1.5. I can even do that one. 4.5. That one I don't remember.
20.25.
And 6.5. I can do that one because we already did it. Right, if you square negative 6.5 and you square 6.5, they're going to be the same, right? Now, what do you do with those numbers? Add them. Okay, cool. So, there's 8.25s. That's kind of nice. Carry the 2.
116.
So 126.
That's actually very good.
You guys got 126, right? Yeah?
I'm sure I missed a number, but yeah. Oh, that's fine.
Now, what do you do with 126?
Okay, you divide it by
Is that a cat or a dog?
kid.
Maybe.
I was about to say something weird.
Is this
Either
where-
that or it's a math student.
I was thinking that too.
So what do we do with the 126, folks? What do we do with it?
Now, is this where you take the numbers and then minus 1?
Yeah, so how, but what does that give you again?
7.
The variance.
Yes. You take the number of you get when you add all the numbers, and you do the number of numbers minus 1, right?
Why
There are
minus
8
1?
numbers.
Y minus.
Y minus 1? You will learn that if you take my statistics.
Oh, that's right. You did tell me that, and I thought, yeah, that's never going to happen.
What? Yes, all of you.
I'm
Really?
so
You think
excited
I
that
need
this is my
statistics?
only math class.
Yeah, this is the only math
For the whole rest of my schooling.
Oh, no. You think this is your last math class.
Effort.
You'll all take statistics eventually.
No.
Yeah. You're looking
Yeah.
at me and saying
Don't
that.
have
I
to.
doubt that.
You wish you don't have to, but you will.
Is it easier than this class?
No.
Not even close.
Most definitely.
It is more fun than this class, though.
Doubtful.
Yeah, it is.
Probably
You
not.
can ask Haley, she's taking it.
Yeah, great. See? Did you hear the voice?
I heard no.
Like she's too polite to be like, I hate it.
I heard no sarcasm in her voice whatsoever. Luckily, the microphone doesn't give those vibes off. All right, so sorry. What's 126 divided by 7?
18.
Straight up 18, which is nice. That's your variance. How do you then get the standard deviation?
Squared.
Alright. Standard deviation is just the square root of that 18. What's the square root of 18? Again, I should say approximately 4.25, because it's not exactly 4.25. But rounding to the hundredths, that's pretty
The
good.
No,
next number
no,
is
no, no, no.
2,
It's
so
4
it'd be
'cause it's a
4
2.
and 4.
Oh, sorry, what was that?
It was a 4.24.
4.24, okay. Sounds good.
I won't say.
Definitely round correctly, thank you. Alright. So, not bad, folks? There will definitely be a question that asks you to calculate standard deviation. So, have this in a way that you will be able to recreate it on the test, please.
We need this book.
You will bring the business math handbook, yes. Alright, not bad? Alright, so how about the next one?
No,
I did not get that far.
no.
Here's a frequency table. Find mean, median, mode. And in theory, create a bar graph.
Yeah, there's no room. Don't even go there.
Yeah, you great one.
Yeah.
Nice.
Look at you overachieving over there. You're probably the only one.
No, I'm sure other people like to draw bar graphs. There's nothing wrong with them.
Give him an A.
I give you an A.
That's all it takes. I'll draw all the bar graphs you need for me.
All right, so when you have a frequency table, folks, what are you going to do to find the mean?
Write them all out.
Right.
You do 10 times 12 plus 20 times 5 plus 38 times 4.
Multiply, right? Because remember, that's what these numbers mean, right? The frequency means that there were 12 10s, that there were 5 20s, that there were 4 30s, that there were 8 50s, etc. down the line. Oh, what is that? 1040?
Yep.
All right, once I multiply all the numbers, what do I do with those? Add them up.
17.
Hmm?
17.
What do I do with 1780? Y 42. Don't forget to add up the frequencies to figure out how many numbers there are, okay? Don't just divide by 5 and tell me that the average is, 370 something, right? When the numbers are all between 10 and 80, the average can't be 300, right? That makes no sense. So, the mean 1780 divided by 42. What did that work out to be? 3, 8. Please round accordingly. Median. There's 42 numbers, folks. It's even, therefore.
There's going to be 2.
There's 2. Which 2 are the middle ones?
21's one of them.
21. Oh, I see.
The 21st number.
The 21st and 22nd numbers, yes. So please note that in position, you're looking for the 21st and 22nd number. So if you're going to write the numbers out, at least only write out the first 22. Because then you can stop, right? Because you know the last 2 numbers are the 2 in the middle. You don't have to write out all 42 and go bang, 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 bang until you get to the middle, right?
Are we going to get extra credit?
No, not at all. You're going to get a sad face.
He doesn't want to look at it.
Because I don't want to see all that crap. I want you to tell me what the 2 numbers are in the middle. So how do you find the 21st and the 22nd number, folks? What are the first 12 numbers? 10. What's 12 plus 5? So the 17th number is the last 20.
When we have it set up like this and we're looking for the median, is it always going to be, like obviously you can find the middle one just by, but then is it always going to be the middle and the one above it?
Yes, always the middle and the one right past it.
Okay.
Yes. Mm-hmm. So, 17 and 4. So the 21st number is your last 30, right? So therefore the 21st number is 30. What's the 22nd number then? 50. So what's the median if my 21st and 22nd number are 30 and 50? Alright. And then last but not least, the almost freebie one when you have a frequency table. What's the mode? 80, right? Because there's 13 80s. That's the most frequently repeated number. $80. Mean, median, mode. I assume you don't need me to draw a bar graph, but The idea is that you could if you wanted.
Yeah.
All right.
Hell no.
Not bad.
Are we gonna have to draw like a lot of graphs on the test?
But I might ask you to draw one.
So like one max?
Yeah, one max.
Isn't it a bar graph?
Maybe. Might be a line graph.
Sounds
Could
like
it
a
be-
pie
could it be a
thing
bar
crap
graph?
to me.
Bar graphs are so much more
Yeah.
fun.
Make it a bar graph.
Tell you what, I'll make it either for you. How does that sound?
Okay, great.
No, there definitely
That means
will
we
be
get
a
bunch
pie
of bar
chart.
graphs.
Okay? There will definitely be a pie chart, right? Because I like pie charts. Because on pie charts are always going to be percentages, and this whole class has been all about percentages, so you should expect to see pie charts and questions about percentages. Alright? Alright, so, given the data, what percent of sales were from items A and B? And how'd you figure out 21%?
37,
41, sorry, that's probably what you said.
18,
29% plus 12%, 41%. If I give you a nice, easy question, please take the 3 points and run.
When you have a question like this, is it always going to be you want the sum of both of them together, or are you going to want them separate? Like, you're going to want to know what A is on its own and B is on its own.
If I tell you, if I want to know what A and B is, I will tell you the sum of A and B.
Oh, okay.
Right? I will say the sum. I'll be more explicit. Yeah, in theory, I didn't say that you should have added them, but the idea is that yes, you should have. All right, so how about the next one? How many dollars of sales were not from C and D? So how do you do this one?
Add them all up and then subtract them.
Figure out what 28% of it is,
Figure out what 28% of it is. Why 28%?
because that's the percentage of C and D.
All right, so C and D equals 28%. Now, how do I use that? What the heck do I do with it?
Multiply it by the 3780, and then whatever you get, you subtract it.
So take the fact that I have 3780 times 0.28. What is that?
I didn't actually do it.
This,
I just know how.
if you did it the other way, there's nothing wrong with it, right?
Oh, okay.
1,058 and 40 cents. And if you figured out that was how many sales you had in C and D, how would you find not C and D? Subtract, right? So 3780 minus 1058.40, well, whatever that works out to be, 27,
2160.
2160. That is one way of doing it. How else could you do it?
I could just multiply it by 0.72.
You could have said not C and D is 72%, right? If C and D are 28, then the rest have to be 72. And then you could have just said, what's 3780 times 0.72? Nicely enough, 2160. Either way you went around it, you were going to get the same answer, okay? Again, some mix-up on the variation there, I would ask. And then last but not least, the fun question. If there were an additional $220 in sales of item A, what percent would A change to? And then it says, be consistent with the graph, whatever that means. So if there were really an extra $220 that we need to put into item A, what would we do?
Wouldn't you add the 220 to our original total?
All right, good. Don't forget to add it to the total, too. Because our total is going to change from $3,780 to a nice even $4,000. But now what are we going to do with A?
Do you multiply it by the old percentage?
Yes, multiply by the old percent. What was A used to be? 29%. So to figure out what your sales in A used to be, figure out what 29% of 3780 was. What was that number?
$1,096.2.
2.
Yes.
What do I do with 1,096 and 20 cents?
Subtract that. Okay.
Because that got added to my sales in A. This was the amount that I thought I had, but I really had $220 more of sales in that particular item. So my due dollar amount in A is really $1,316.20. Now how do I convert that into a percent? Divide by the total. So what's 13, 16, 20 divided by 4 grand? 329.
Yep.
Note that's the decimal. What are you going to do with it? Yeah. Move the decimal over to. Am I going to write 32.9%? Why am I going to write 33%?
Because you round to
Because what did I say in the end of this question? Be consistent with the graph. What were my percentages in the graph to begin with?
no decimals.
No decimals. If there are no decimals, don't give me decimals in the new world, right?
Technically, we're still correct if you put down 32.9.
You're not incorrect if you put 32.9. You're just not really being consistent with the graph, which would make me sad and probably cost you a point.
Yeah.
Again, this is one of those things where if the graph has to change, folks, you do want to be consistent with whatever you were doing the first time so that you don't confuse people by all of a sudden having a bunch of numbers that have decimals and a bunch of them that don't, and they're just looking at you like, what the hell are you doing? Don't you know math? I mean, it doesn't really matter, but people will think that you're doing things incorrectly if some of the numbers have decimals and some of them don't, okay? It makes them scared. Scaring people when you're doing a presentation is always bad, unless you're teaching, in which case then it's good.
Sometimes you just gotta learn a little.
Yeah, I agree. All right? So, and just for kicks and giggles, folks, what's the new B percentage? So we didn't add any numbers to B, but it had to change. Why did it have to change, first off?
Now it's out of the graph.
Yeah, because the total changed, right? Since the total changed for every category, every percent had to change. How are we going to figure it out?
31% or something. Figure out how much.
What was B before?
12%.
Oh, I was looking at E.
So would you take it then
12% of the
old?
old.
Yeah, use 12% of the old number, right? What was 12% of our old sales total?
453.60.
Now, does that number change? No, right? I mean, it stays the same because I didn't have any more sales in B. But then what do I have to do to change the percentage?
Divided by the new total?
Yeah. So the new percentage is going to be 453.60 over 4,000. What does that change us to?
11%. 113.
So we dropped a percentage point from 12 down to 11. Not bad. Again, this is just working percentages and making sure that you keep working the numbers correctly. There are no nice, easy shortcuts where you can say, well, if the percentage went up by 8, you can just have all the other percentages go all down by 2, right? No, doesn't work that way. Would be nice, but it isn't. Okay, all of these numbers are weighted, so some of them may drop more, some of them may drop less. Do the calculation and verify. All right? All right, cool. You know there's going to be one of those, and you know I'm going to make it fun, too. All right? All right, how about the last one? Standard deviation, normal population stuff. So one of the tests I gave had an average of 73 with a standard deviation of 7.5, and I claimed that it was normal. None of my tests are ever normal, folks, so don't worry about it. But let's just pretend that it was. So, first question, what range of scores are within one standard deviation of the mean? What is that question asking for?
They're asking for the 7th and the 8th numbers.
Not quite. What was that? It's about the bell curve, yes. But what numbers or what range of scores, what values, what grades, if you will, are within one standard deviation of the mean? I mean, what do you have to do to be within one standard deviation of the mean? Yeah, one above and one below. So what grade or what score is one standard deviation above the mean?
You would add 7.5 to 73.
73 minus 75, 7.5, 73 plus 7.5. What is 73 minus 70.5? 65 and a half?
Yes.
You need the answer to the next question. Don't you?
So the idea is that the range of scores within a standard deviation of the mean are between 65.5 and 80.5. Between 65.5 and 80.5. So if I ask for the scores, then I'm just looking for a number, okay? When I start asking for percentages, that's when you guys have to draw the bell curve, okay? You will do that, period. Well, you don't have to. You can just guess if you want. So as soon as you see normal distribution, folks, you should basically draw a bell curve. Now, what goes in the middle of the bell curve?
73.
73. Awesome. There's going to be 2 lines to the right and 2 lines to the left. How are you going to figure out the values of those lines?
First one's going to be a standard line deviation, so it'll be simplified. So the lower one to the left should be 65.5.
Add and subtract the standard deviation each time you hop to a line, right? So the whole 65.5 and 8.5, you already did those 2. You should know they're there. To get to the second lines, just do it again, right? Add another 7.5, 88. Subtract another 7.5, 58. Now, what are the percentages between those numbers?
This one's 68%, does that sound right?
But it's divided in 2, so
So it'll be 34.
34 is right here. Remember, this is symmetric, so the numbers are the same going out. What are the next 2 numbers?
13%, or 13.5, sorry.
13.5 and 13.5. And then last but not least on the outside edges,
2.5.
2.5 and 2.5. The numbers in blue, folks, up there are always the same for every normal curve, okay? Always. The percentages are always the same. That's what normal means. The only thing that changes are the numbers down below based on whatever your mean and standard deviation are, right? So if these numbers, if the mean is something else, you'll start at a different number. If the standard deviation is a different number, you will add and subtract it to get to the different values. So, now that you have this curve, now you can answer the questions. What percent of my students scored an 80.5 or more?
80.5 or more.
80.5 or more. So, what does that mean?
Would we just be?
Maybe 16%.
16%, right? Because it's the 80.5 or more. So add up all the percentages that are basically covered by this line. So basically 16% of my students got a B or higher. Okay? And then the next question is, what percent of my students scored between 65.5 and 88?
Just add 34, 13.5, right?
Yep. There's 65.5 to 88.
81.5.
34 plus 34 plus 13.5. 81.5% of my students got between a 65.5 and an 88. So, the cool part about this, folks, is that the normalcy is really fixed, right? This normalcy drives the percentages being the same. The only thing that changes along it are the numbers along the bottom. All right? Okay, well, there's your review. Now, how about questions on the homework in chapter 22?
16.
Number 16.
Excuse me, 18. Sorry,
18?
18.
Okay. Which one was number 18?
Ready?
Mm-hmm.
Despite tuition skyrocketing, the college education is still bad. Okay. Recent calculation by the Federal Reserve in San Francisco demonstrated college degree is worth $800,000. Okay. If graduates in 2017 earned $40,632,
40,632.
35,554,
35,554.
42,192,
40,000, 2,192 or 192?
42,192,
Okay.
33,432,
Okay.
69,479, and 43,589. What is the standard deviation for this sample?
Find the standard deviation of these 6 numbers.
Do you know how big those numbers?
Oh, aren't they awesome?
Yeah, well, calculator.
This is good stuff, folks, right?
No, it's not.
Yeah, it is. All right.
Just want to make sure I did it right.
Note, it would be nicer if these numbers were in order, but I didn't write them in order to start with, so we're going to have to deal with it. So what's the first thing you have to do if you were asked to find the standard deviation?
The mean?
Find the mean, exactly. So what is the mean of those 6 numbers to start with?
24,146.33333.
44,000, what was that again?
44,146.
146. And if you
Point
looked, in the problem, what did the problem state?
Tells you round to whole number.
Okay.
Round to whole numbers. If you use decimals, that's perfectly fine. I'm okay with it. Don't erase everything because you did it. It's okay. Okay? But yeah, just realize you didn't really need to. Okay? So, what am I going to do now that I have the mean?
Subtract them from each one of the numbers.
Exactly.
Yeah.
So what's 40,632 minus 44,146?
I think it's a negative 10,715.
You have them in order, I don't.
Oh, I'm sorry. 40,000. Negative
1.
3,514.
3514, yes. All right, now how about the next one? Again, remember I'm not in order.
I'm sorry, I put that in order.
44,146.
Negative 8,592.
592. I'll buy that one.
Negative 1,900.
Whoa, wait for it, wait for it. What was that?
Negative 1,954.
54, 1954, yeah. Uh-huh. Ooh, this next one's nasty. 33, 432 minus 44, 146.
Negative 10,714.
Yeah.
714. I like it. 69, 479 minus
25,332.
33.
33. Right, because it's a 9 minus a 6.
That's okay. I don't feel bad.
And then last but not least, 43,589 minus the 44146.
Negative 557.
All right.
Yeah. I stepped-
Awesome.
I stepped kind of right there.
Well, there's nothing wrong. Those are just numbers, right? You guys can handle
Till
numbers.
you do the next step.
Now what do you get to do?
You get to do the old.
Square.
Square it. Well, so what is 3,514 squared?
12,348,196.
Okay. 8,592.
73,822,464.
1954.
3,818,160.
10,714.
You're having fun with this
Well,
one.
this is great.
114,789,796.
6. Sorry.
Yeah, that's.
And then last, or not quite last but not least, 25,333.
333, you said?
25,333.
$6,417,000,000.
Whoa, it's not
wait,
quite
no,
that
sorry.
big. 600
I'm
something.
just reading it out my calculator.
Gotcha.
Yeah, 641,760,800.
889.
Yeah.
Okay. And then last but not least, the little teeny weeny number, 557. Not even a million. Who cares?
310,000.
310,000.
240, not 800.
2.
When I punch up, I've got 114 million. I'm going, I don't know if I'm doing this right.
No, sometimes the numbers are big, folks.
No.
This is why normally to do these calculations you want to use a spreadsheet program, right?
Yeah.
Because doing this, I mean, it's doable, right? I mean, you can get the numbers. You just have to be careful and take your time. It's okay. But yeah, it's kind of silly. But this is me trying to point out to you that this stuff is normally done through computers, and that's who should do it. But again, you need to know so that you can appreciate. All right. So what are we going to do with all those numbers? Add them all up. Sweet. Awesome.
Divide by 5.
So when you add them up, what do you get?
Go up.
10, 22, 31, 40.
You can do it in your head. Come on. Just rattle it off.
Is that 789 or 75? The third
7,
one.
8, 9.
Yeah, this is an 8.
I don't think the calculators will go that whole way.
17, 25, 27. Area 2. 10, 20, 29, 29. Area 2. 6, 10, 11, 19, 26. 6.
908,323,978. Jesus Christ.
What?
Unless I missed a number or something. I got 908,323,978. Did I miss a number or something?
It has to end in a 0. That's for sure.
Oh, well, yeah.
10, 12, and 18 definitely adds to 40.
give up. I'm not
Yeah.
recalculating all that. Are you
Hey.
kidding me? I just typed in like 80 numbers.
Or 15,
Okay.
whatever.
497. I
I
got
meant individual
eight
numbers.
846,849,710. Does
849.
that sound right?
Sounds about right, yeah.
Well, I got the 710.
Sounds about right. It should be around that number. What do I do with that number?
Divided by 5.
When you divide it by 5, what do you get?
169,369,932.
932?
42.
42. This, folks, is the variance. What did the question ask for?
Now you square it.
Square rooted.
Square it.
Yeah. So the standard deviation, now take the square root of that number. 13,000 something? $13,014. Again, round to the nearest whole number, so that's just the standard deviation of the numbers. And note, I mean, 13,000 compared to the numbers that we have up here, numbers between 33,000 and almost 70,000,
That's a lot of. That's a lot.
it's just a lot of numbers, right? But this is why calculating standard deviation in this class, I've kept our numbers to being 2 or 3 digit numbers at the most, because once you get up to 5 digit numbers, folks, it gets hairy. And imagine if these numbers were 6 and 7 digit numbers up there in the millions, right? Yeah, this would be painful. Again, this is stressing the whole fact
It
that...
is, though, already.
And note that I will only give you 1 digit or 2 digit numbers at the most on the test. Okay? So, I should give you one like this just so that, you know, you can appreciate it, but we did it once on the homework, therefore we're done.
It's fine.
Alright, not too bad? Alright, any others?
16.
16? Alright, which was number 16?
I don't know. I don't have
It's drawing a line graph.
Drawing a line graph?
Oh, yes.
Okay, what's the line graph ask you to draw? I need data.
Okay, sorry. The first Super Bowl on charged $42,000 for a 30-second commercial. Create a line graph for the following Super Bowl 30-second commercial cost.
Okay.
In 07, it was $2,385,365. 2008, it was $2,699,963. 09, it was $2,999,960. 2010, it was $2,954,010. As you're saying. 2011, it was 3.1 million. 12, it was 3.5 million. 13 and 14, it was 4 million. In 2015, it was 4.5 million.
How much in 15? 4.5?
4.5. They were even numbers, so I figured I'd just rattle it off to you like that.
So first off, note, folks, Super Bowl costs. Not cheap, right? I mean, think about absorbing that much to run a 30-second ad, right? And think about how many of those commercials actually run multiple times, right? This is, every time they run, that cha-ching. This is why the NFL is
Lucrative.
makes a decent amount of money. But remember, folks, that the National Football League technically is a non-profit organization, right? They make zero profit off of their $4.5 million 30-second TV commercial. Granted, guess how much the president of the National Football League makes as a salary every year?
4.5.
A little bit more than that. He's making somewhere between 8 and 9 million right now. Again, though, nonprofit, right? The organization makes no money. They give it all away, right? I mean, the NFL does a whole lot of charity work. They really do, folks. And this is kind of why, because sometimes they have so much money left over, they just don't know what to do with it. And they can't have it as profit, so they have to give it away. Or pay it as salaries. This is also how profit sharing works in a cooperative business, right? Note that a lot of this money goes back to the teams. This is why NFL teams can pay their players as much, too. So how would you graph this?
I put the dollars on the, I'm sorry.
You put the dollars on the left,
Right, and
years along the bottom. Good idea.
then I put each line of dollars, 1 through 5. And
1
mark
through
it
5?
as millions with a legend off to the side.
Very good idea. And then what did you say off to the side?
And
You
then
say
I could put
in
millions,
millions, right?
you know.
So that you don't have to write all those stupid numbers out, right? I mean, that's the whole point. This is why you graph this crap. Because you don't care about whether it's 2.6999963 or whether it's 2.6888472. Those are both going to look exactly the same on the graph, right? But you're going to get close so that it looks like it's a decent deal, right? And then along the bottom, you'll be 07, 08, 09, 10, 11, 12, 13, 14, 15 years after 2000. Again, so that the 07 looks like 2007 and 08 looks like 2008, right? Because if it was the year 7, remember that the NFL didn't exist in the year 7 AD, right? There was no football yet. All right, and then it's just plot and draw, right? So 2.3 million. Where is that? Well, it's about right
About
there.
two, yeah.
Uh-huh. Where's 2.7 million? That's a little bit higher. Where's just a shade under 3 million? Well, just make it 3 million.
And then 2.95.
2.95. It does go down just a tad bit there in 10.
Then 3.1.
3.1. Then it goes back up again, but just a little.
3.5.
3.5.
Then 4 and 4.
4 and 4.
And then 4 and 5.
And then 4, 5. And then you get to connect the dots.
Hold on.
And there you go. So make a nice little picture.
Except you do have to put a dollar sign somewhere along there, right?
True. So again, pictures, I mean, is this a meaningful picture? Hell yes, compared to looking at those numbers, right? That's the whole point. This is the sort of thing that you want to see to say that the NFL is making good money, folks, right? Because you look at the graph going, oh yeah,
The president makes 31.7 million.
31.7 million now?
That was just in 2015.
It's been a while since I've looked. Tells you what I know, right? And yes, does that surprise you given how much it costs to buy a 30-second ad? The guy who's running the NFL makes $30+ million a year?
The mascots make like 60 grand a year.
Seriously?
Yes.
Oh
I
shit, we need to run for mascot. Holy crap.
You're doing the wrong thing.
Yes. What the hell am I doing?
Yeah, forget dropping out and being a stripper.
Okay.
Drop out and go be a mascot for that.
Our boys make 53 grand a year.
Oh, no, we're definitely in the wrong profession. Serve water for $52,000.
You have to show up at the football game every weekend, though.
That's perfectly fine. Perfectly fine.
Hey, you get to travel.
Yeah.
And you get to be at football games. I mean, that
Well, you don't get to
itself
watch,
is-
though. You have to actually be next to a guy going, do you want more water?
That's fine.
It's worth it.
I don't want to know these
I
things.
feel like I can twist my arm.
Tell you what, I'll only take 45,000. I'm nice. Right.
No,
All right, so not too bad. Did you guys do okay on the percentage question on the optional stuff at the end? The not optional stuff?
Mhm.
Not optional.
Yeah, it's called optional, but it's not.
I want to know what pages, like which ones those are.
Are you talking about the challenge problems?
No word problems.
The extra problems on page
Drill
2.
problems.
Right.
Drill problems.
The drill problems that are labeled optional but are not optional.
What? We have to.
Yeah.
Yes.
2,
So on
4,
page
6.
551,
Oh, okay.
2, 4, and 6, right?
Yeah.
Okay.
Oh, okay.
I was very confused.
Yeah, I was too.
Now you're not.
Shows you I haven't
I'm
even
so
looked at the
confused.
homework yet.
That doesn't surprise me.
Usually I've got some of it done by now.
Alright, so folks. Not bad? If you haven't finished your homework, please finish it by Thursday and turn it in. If you are happy with your homework, folks, I would love to have it.
We only did 2 questions, you do know that, right?
What?
Yeah, we only did two.
We only did 2.
Oh, did we only do 2?
Yeah.
Oh, do you need a third one?
Someone pick a long one.
22.
Is that one?
20.
Oh, 22, yeah.
Yeah. Okay,
22
do
just
that
the
one.
line graph?
Yeah, but it doesn't make a lot of
Okay,
sense.
don't do that. We got
Okay.
30 minutes because you're too.
Okay.
Sounds like you were gonna let us out early.
Yeah.
Yeah.
Nah, that ain't good.
Full
Would I ever
crap.
let you guys out early?
No.
No.
Why wouldn't you today?
It is December.
We already reviewed.
Is this our last thing? Like, this is it, right?
Well,
Last chance.
Thursday you take a test.
Yeah.
Tuesday next week you get the test back. We go over it. We review for the final.
And then the
The
final.
Thursday is after that is the final, and then you get out of here, right?
Yeah.
No, like,
So,
No practical.
Oh yeah, obviously.
You get a full seat.
Yeah, you get a full sheet for the final.
all that.
You get a nice big note card for this next test. You can make it up to a half sheet.
And stay
Perfect.
8 notes. So we can get out early? Is that what you're saying?
If you don't have any more questions, I am happy to go early. But if you would like to go and review for the test, remember there's chapter 14 and 15 still. If you have any questions, I'd be happy to go over them. It's completely up to you guys. This is your time and your money.
Let's go over 22.
let's go over 22.
Let's go over 22.
Yeah.
Did you read it?
No, I trust you.
It's just
What does 22 say?
I can't read.
the United Nations states the gender pay gap will not close for 70 years. Women across the world earn 77 cents for every $1 of what men earn. Construct a bar graph reflecting the following Harvard University study on pay for women based on $1 for men.
Okay.
Financial specialists, 66 cents.
Well,
Physicians,
hang on. Financial specialists, how much?
66 cents.
66 cents, okay.
Physicians, 71 cents.
Physician, 71 cents.
Aircraft pilots, 71 cents.
Pilot, 71 cents, okay.
Accountants, 76 cents.
Accountant, 76 cents.
Lawyers, 82 cents.
Oh, those are a little better.
And nurses, 89 cents.
Almost legit. That it?
Yeah.
Okay. Line graph or bar graph, did it
It
say?
says bar.
Bar graph? Oh, okay.
Yeah.
So on one axis, would you have like
That's where I was trying to blank.
the money, but in parentheses, wouldn't you put like
For $1.
yeah per $1 per
Uh-huh.
month or something?
Yeah.
Per $1 for a man. Okay.
And then on the other one, you'd have like
The
the career.
Profession or career,
Yeah,
that
yeah,
works.
that
Mhm. Works for me. And so what do I need to have up here? You know, up to 89 cents, so like up to $1. So here's 25.25, 0.50, 0.75,
And then I'll
1. And then we can
FS.
financial specialists, where do they go? 66 cents. That's pretty good. What's next
71 cents
for physicians? 71 cents, so a little bit higher, but not the 75 cents yet. What's next?
71 cents for sales.
Oh, that's for the pilot, right? Pilots are the same 71 cents. Accountants, 76 cents, getting up above that 75 cent mark.
Lawyers, 82.
Lawyers, 82, a little bit higher. Last but not least, the nursing, 89.
And then, would you do a legend for this or no? Because we're not connected.
Yeah, there's not really any additional information that you can throw in there. So in this case, you probably don't really need a legend. You could, I suppose, we could have like abbreviated all of these names, A, B, C, D, E, F, G, and then up in the legend said financial specialist, so we could write it all out and have it fit. I mean, that could be something you do. Again, though, this is get the problem done, get it right, make sure you get the points, crank it out that like this, and it's all good. The sad thing, of course, is that this makes it look like women are not doing as bad as they really are, right? Because all the bars are really tall, and the man, would mansplain it to you by saying, "See, women are doing just fine," right? I mean,
You're doing great.
yeah, right, exactly. That's what I should say.
But in reality, if we did a second set of bars showing what the men make for
Well, that's
Right, yeah. Yeah. Uh-huh. That would be a better graph if you had those with you. All right, folks. Please be ready on Thursday.
And then you did say the review for the final is online?
Yeah, the review